Hello and welcome to another session of Mindful Data Mine. In today's session, we will be discussing about another very powerful SAS procedure which is used for running descriptive statistic as well as checking important assumption of various statistical techniques such as normality, detecting outlier, etc. We are talking about the procedure univariate, also known as Proc Univariate. So without wasting any further time, let's start with the practicals. So the general syntax of proc univariate is PROC univariate followed by the dataset name. I'll use SAS help dot choose here. Okay, and in the end we need to use run. So if I directly run this procedure, by default it generates the result, and if you see it says variable is stores. It generates 5 basic statistics like movements, basic statistical measures, test for location, quantiles, and extreme observations. All these are related to variable stores. Okay, moving further, then again it's changing the variable is sales, and again it's generating the same movements, basic statistical measures, test for location, quantiles, and extreme value. So these are the default items which are generated by proc univariate. I'll pick maybe one of the variable. Let's say I'll pick up maybe sales. Okay, and I rerun to discuss more about the statistics. Now, if you see the moments, we are getting number of observation, mean, standard deviation, skewness, coefficient of variance, kurtosis. We are getting sum of observation, variance, weighted sum, standard error mean. For basic statistic measures, we are getting mean, median, mode, standard deviation, variance, range, and interquartile range. Then we are getting test for location, quantiles, and then the extreme observation. We are getting 5 lowest values and 5 highest values. So these are the statistics which we receive or which we are able to see when we use proc univariate. Okay, moving further. So in case if I want to do any analysis, let's assume we want to do analysis of sales by region. So I'll use the same proc step again, and this time I'll change or I'll add region to it. So what this class data what this class statement will do, it is mainly used for categorical variable where we have different categories. Okay, and when you want to analyze sales by region, it will help us in generating based on the categories. So if you see, we are getting results for Africa, then we are getting it for Asia, Canada, Central America, and so on. In this way, in case if we want to analyze sales by region, we can do it. Now let's assume that, okay, we want to analyze sales by region, but we only want to analyze quantiles. we do not want to analyze anything else, or we just need in the results we only want to see quantiles, not the all the other items. So if we want to do that, what we can do is I'll just copy the same code, and here we need to use ODS select quantiles. When we use this and run it again, I'll be able to see quantiles only. Okay, now we have these quantiles available. Now my next requirement is we have these quantiles, but I need this in a data set. Okay, I do not want this in result, but I need it in a data set so that I can retain it and I can use it for future purpose. In that case, what we can do is instead of using select, we can use output here. And after quantiles, we can mention the dataset name. Let's assume I'll write sales QTL for quantile, and in the end, we'll close the ODS. Now, when I'll run it, a dataset will be generated in which I'll get the quantile details. Similar to this, in case if we want to get extreme observations, so what we can do is instead of quantiles we need to use extreme obs. Ext, that's what I'll update here so that we can get a new data set, and in the end the output is getting closed. So when I'll run it, I'll get the extreme observations. Okay, so these are my low and high observations. Now moving further, in case if I want to plot a histogram, we can use Proc Univariate for the same. For that, we'll need to write Proc Univariate data equals to SAS help dot choose where sales, and here we'll write histogram normal, and maybe color if I want to give blue color. Now when I'll run it, let's see what we get. See, we are getting it like this. And in case if we use no print and then run it, we will be getting histogram directly. Moving further, if we want to do the test for normality, we can do it using Proc Univariate again. So for that, what I'll do is I'll copy this code, paste it here. Now I'll remove this histogram from this because we do not want it and we want to do the normality test. We will remove the no print also, and here I'll use an option known as normal. So this is used to request for normality test. Okay, if I run it like this, since this is the default version, so we will be able to see everything like we used to get. Here, in case if I want to select only the normality test, then similar to what we did for quantiles and extreme observation, I can use ODS select test for normality semicolon. Now when I'll run it, I should be only able to see test for normality. Okay, now let me just run the default code first so that I can explain you better. If you see here, we are getting quantiles 0%, 1%, 5%, 10%, 25%, 50, 75, 90, 95, 99, 100. These are default quantiles or percentiles. But in case if we want to customize this, okay, in that case we can again use Proc Univariate. Okay, let's assume I want to find percentiles 10%, 20, 30, 40 up to 100. So for that we can use Proc Univariate again. So what I'll do is I'll quickly copy the same code from above, remove normal from here, and maybe I'll keep no print this time so that it doesn't print anything. Okay, and if let's assume I want to output the data as well, so for that I'll use output statement followed by out. Okay, and here I'll mention maybe pctl underscore data. This will be my dataset name, and now we will use the dataset option as pctl pts equals to 10, the starting part, to 100 by 10. That is, it will create 10, 20, 30. It will divide 100 by 10 and then we'll get 10, 20, 30, 40, 50 like this. And in case if we want to prefix it with something, then we can use pctl pre and maybe p underscore, so that we can see p underscore 10, p underscore 20 like this. Now when I run it, this should create a data set like this. So pctl underscore data is created and we have these percentile 10, 20, 30, 40, 50 up to 100. So in this way we can create the percentiles as well. Okay, now in case if we want to do test for location or t-test, we can simply perform it in the same way we did it for test for normality. What we can do is I'll just copy the same code, and here because it's not normality test I can remove it, and this time I'll use select test for location. Now when I'll run this should give me only t-test. And last but not the least, in case if we want to plot graphs like histogram, box plot, normal probability plot, we can do that in Proc Univariate. So for that we will use the same code, Proc Univariate dataset name, and here we need to use plot. See, produces a stem and leaf plot or a horizontal bar chart, a box plot, and normal quantile plot. Okay, when I'll run this, this will generate the default data along with the plots. So this is how we can utilize Proc Univariate for doing descriptive analysis. Please let me know in comments in case if you have queries, any question related to Proc Univariate. I'll see you in the next session. Thank you.